Hello everyone, this is Charlie from the Bloomingdale Public Library, and today we will be discussing implementing inheritance in the Ruby programming language. And we're going to cover a related subject called mixins as well. If you haven't seen the video on classes and objects yet, I'd recommend you do so before continuing. So what is inheritance? Inheritance in object-oriented programming is where a new class is created from a pre-existing class, either including or redefining its methods and variables. For example, let's say you already have a person class with an instance variable called name and a method called run. You can now create new classes based off that person class. For example, a baseball player class. That baseball player class would inherit the name variable and the run method, but then you could add other methods and variables that are more related specifically to baseball players. For example, you could add a team instance variable and a throw method. An existing class used to derive a new class is said to be the parent class, base class, or superclass, where a new class derived from an existing class is said to be the child class, derived class, or subclass, and you'll hear all of those used interchangeably. All right, so let's go ahead and code out the example. Again, we're starting with a person class. And this person class has an instance variable called name and a method called run. And all that's going to do is spit out the word running because we want to keep things nice and simple and focus on the inheritance. All right, so there we go, nice simple class. Go ahead and test it out. I'm going to create a variable called object1 and assign it a person object. This object has a name variable. Oops. So let's go ahead and assign that name variable the value Joe. And we're going to spit it out to output to make sure everything is working. So, do puts object1.name to spit out the name, and then object1.run to test the run method. Save it, run it, put your bets on my typing. Oh, and we're good. So hopefully that all makes sense. It's a nice simple program. Again, just testing the functionality of the person class. So from here, we're going to go ahead and create our baseball player class. And to inherit from the person class, all you do is after the name of the class, you put the less than sign and then the name of the class you're inheriting from. That's it. Nice and simple. In fact, let's go ahead and test that out. So instead of assigning a person object to object1, let's go ahead and assign a baseball player object. All right, baseball player. All right, so object1 is now assigned a baseball player object, but we're still using the name variable and the run method from the person class. So we're going to save it, run it, and sure enough, we still have that person class functionality in our baseball player class. Let's go ahead and add some more functionality to this baseball player class. Again, we're adding an instance variable called team. And a method called throw, which once again, all it's going to do is spit out the word throwing to keep it nice and simple. All right. To test out this new functionality, let's go over here, go object1.team. We'll name them the birds. I'm not sure if there's actually a team named the Birds, but I don't want to play favorites. And then down here, we're going to go ahead and test out that throw method. Save and run. And there you go. So again, we're just demonstrating that we can create a new class called baseball player that has all the functionality of the class it's inheriting from, as well as some more that we added later. Alright, so what can subclasses all do? Well, they can inherit the superclass's class variables and instance variables, but not its class instance variables. More clarification on that a bit later. A subclass can inherit the superclass's methods, inherit the superclass's constants, and on top of that declare its own variables, methods, and constants. One last thing a subclass can do is override a superclass's method. Now what do I mean by that? I mean if you have a method with a certain name in a parent class, and then you declare a method with the same name in the child class version of the method wins out. It completely replaces the method in the parent class. Now in that child class, you can use the super keyword to actually call that same method in the parent class. And if that doesn't make sense, don't worry. I will give a demonstration a little bit later. If you're coming from another language, it's worth noting that Ruby does not support method overloading. The subclass method will always override the parent method regardless of the method's signature. And by method's signature, I mean a method's name, arguments, and return value. So basically in other languages, if you have a method, like say Go, and you have this Go method with 0 arguments, and then you have another method called Go with 1 argument, and another method called Go with 2 arguments, those are all considered separate methods in certain other languages like Java. In Ruby, that is not the case. Regardless of the signature, the child method will override the parent method, regardless of how many arguments each one has. Okay, so let's have a quick look at overriding methods in a parent class. But before that, just as a bonus, I want to talk about comments real quick, since I haven't done that yet in any of my videos. To make a comment in Ruby, all you do is put down a pound symbol, and that's it. So after the pound symbol, everything else gets ignored when it's time to execute your program. So something like this just gets ignored when it's time to execute your program. You can also put a comment at the end of your line. Everything before the comment symbol will still be executed. Everything after still will not. So save and run, and sure enough, everything executes just as it did before. So people will use comments to make their code more readable, maybe describe what's going on to either other people or themselves in the future. So many programs that I've written, I couldn't tell you what's going on now without the comments. But the main reason I wanted to bring up comments is for another purpose that they're used for, and that's debugging and testing. So we wanted to have a look at overriding this run method here in the parent class, but we've got a whole bunch of extra output here that we don't really need to worry about for this purpose. So instead of deleting it, we can just comment it out. So if I save it, run it, you see now we're just worrying about running and nothing else, which is what we want. If we wanted to put everything back later, it's just a matter of taking the comments out versus having to retype it all over again. So getting back to the matter at hand here, let's go ahead and define a run method in our baseball player class. And instead of running, the baseball player will really be running in caps. Alright, so if I save and run that, sure enough, instead of running lowercase, we're running in caps. And just to demonstrate that we can't overload in Ruby, we'll go ahead and accept an argument called speed, and we'll put it in the printout here. And we'll make this baseball player fast. Alright, so we'll save it, run it. Sure enough, now we're running at 20 miles per hour. If I take away the argument, save it, run it, we get an error. In other programming languages, this call here would actually just go to the version in the person class where there's no argument. But again, in Ruby, that's not how it works. The child version will override the parent version regardless of how many arguments are provided. So that just about covers the basics of implementing inheritance in Ruby. There's a bit more that can be said, but I'm going to briefly go over class instance variables and then move on to modules and mix-ins. I mostly want to cover this topic because I kind of messed up talking about it in the previous video, but class instance variables are also a notable exception to Ruby inheritance, so they're worth noting here as well. Instance variables declared outside a method are called class instance variables, or some people call them instance variables on a class. In my previous video, I wanted to demonstrate why you should assign values to your instance variables inside methods instead of outside methods, presuming that you were overriding the values when you created a new instance of a class, but that was incorrect. What I was actually doing was creating two separate variables at different scopes, and scope is a topic for another video. So class instance variables are a side effect of Ruby's everything is an object design, because even classes are objects of the class. Class instance variables are accessed with class methods, and those methods will start with the self keyword followed by a dot, and class methods are called on the class and not an instance of the class, and I'll show an example of that in just a sec. Again, class variables are inheritable while class instance variables are not, which is why class and class instance variables are a common cause of and solution to a bunch of inheritance problems you'll run into as you use Ruby. So here's some examples to have a look at. On the left side, we have a class instance variable here called @PowerLevel. You can either just declare a class instance variable or assign a value to it, either way. Whereas on the other side here, we have a class variable called PowerLevel where you have to assign a value to a class variable. Below that, we have an example of a class method. Again, it looks just like a regular method, except the name is preceded with the self keyword followed by a dot. Incidentally, you do not have to declare a class instance variable outside of the method. You can declare one inside of a class method as well. So below that, we demonstrate how to actually call this self.setPowerLevel method. You can either use the name of the class, followed by a dot, and then the name of the method, or you can create a variable that holds an instance of that class, and then use the variable name, then a dot, then the word class, and then a dot, and the name of the method. Now, if you were inheriting from these classes, on the left side here, you would not be able to inherit the class instance variable @PowerLevel. However, on the other side, you would be able to inherit both of these PowerLevel variables. If you're familiar with other object-oriented programming languages, you might be wondering about interfaces, since those usually go hand in hand with inheritance. If you don't know anything about interfaces, that's okay. We'll talk about them a little bit right now. An interface is an object-oriented concept used to describe how to interact with an object, usually a collection of public methods. You might recall I described a class's interface in the previous video as its collection of public-facing methods. Some languages, however, have interfaces that are completely discrete from any classes. They're their own collection of methods, which you could then implement on multiple classes. Interfaces are sometimes described as a way of emulating inheritance of multiple classes. To use Java as an example, it's just like Ruby in that you can only inherit from a single class. However, you can implement multiple interfaces. An explicitly defined interface in Java is actually just a collection of method signatures, meaning you only have the method's name, arguments, and return values, but no body. It becomes up to the class implementing the interface to actually define the bodies of the methods. Just for an example, if you were to create an athlete interface with jump and climb method signatures, and then you create a baseball player class that implements that interface, it too must define both the bodies of the jump and climb methods and define them with the correct method signatures. All that said, Ruby does not explicitly support interfaces. It does implement something called mix-ins, which has a similar functionality, and we'll get to that in just a bit, but first we have to discuss what modules are. Okay, so just one more wordy slide before we get back to some coding demonstrations, and this is Ruby modules. So a module is a way to group Ruby code together, usually to be used in other files or included with classes as a mix-in. In other words, a module will probably be by itself in its own file, and then you'll import it to whatever program you're writing. Modules can contain methods, classes, and constants. A module name starts with a capital letter followed by lowercase alphanumeric characters. In other words, you name it kind of like a class. By convention, a file only containing a module is named after the module in just lowercase. And again, you should be doing that with your classes as well. Modules act as a namespace for the constants and methods they contain, meaning you have a way to reference them in the case the destination file or the code outside of your module duplicates their names. So in the case that you have two constants with the same name or two methods with the same name, you can stick one of them inside of a module and use the module to refer to that constant or method and not have any conflicts. So when you define or call a method from a module, you would precede the name of the method with the name of the module followed by a dot. For example, if you had a module called myModule and a method inside that module called myMethod, you would write it out as myModule.myMethod. You define constants normally inside of the module, but then refer to them outside the module by preceding the constant name with the name of the module followed by 2 colons. So for example, we've got myModule, : and the name of the constant. Okay, so on the interfaces slide, I discussed an interface called athlete. Let's go ahead and make a module called athlete and give it a climb and jump method. So we're going to start off with the module keyword followed by athlete, capitalized. And then we're going to define the climb method, which again we're going to start with the name of the module, then a dot, then climb. Keeping things simple, we're just going to put out climbing, end. And we'll go ahead and define jumping as well. There we go. Just to round it out, let's go ahead and add a constant, and we'll call it speed. So again, constants should start with capital letters, and by convention they're usually all caps. We'll make it 99. And then close up the module with the end keyword. So I'm going to go ahead and just comment everything out for now. And then to execute those methods, we'll go ahead and do athlete.climb, athlete.jump, save, run, and there we go. Just to test out this speed here, we'll go ahead and create our baseball player here. Except we're only going to execute the run method, and we'll go ahead and send it the athlete constant speed. Save, run, and there we go. So that is how you implement a module in your Ruby code. Okay, so let's talk about mix-ins. A mix-in is where methods and constants from a module are included within a class, or you might say they're mixed in. This functionality compensates for Ruby's lack of multiple inheritance or interfaces, features included in many other object-oriented languages. So to create a mix-in, all you need to do is use the include command followed by the name of the module. Piece of cake. Some notes. The methods in a module intended for a mix-in should not be preceded by their module name when defined. That module name is just going to get in the way. This is the difference between having a module method and an instance method. Another note, the module needs to come before the class that includes it. Otherwise, when it comes time to include it, it's not going to know what you're talking about. The code executes from the top down. With all that said, let's turn that athlete module into a mix-in. Alright, so let's use the code we've got here. We'll go ahead and up here, we're going to include athlete. And then down here, we'll go ahead and do object1.climb, since these methods are now instance methods. Object1 dot jump. Alright, and we'll go ahead and comment these other guys out here so they don't confuse us. So save and run. And sure enough, we have an uninitialized constant. And you might remember one of my notes. We need to include the module before the class that includes it. There we go. Save and run. We've got a different error this time. Again, one of my other notes is we have to get rid of the module names before the methods, so we can turn these methods into instance methods instead of having them be module methods. And while we're thinking about it, down here, we don't want athlete speed because we're dealing with baseball players now. And speed is a constant of baseball player. Alright, let's save and run one more time. And there we go. That is how you include a module with your class, as well as a little bit of troubleshooting. One last topic I'd like to cover, and that's importing code into your program. Like I mentioned earlier, it's pretty common to keep classes and modules in their own files to keep any one file from getting too long and to make things reusable. And you bring code into your program with the require command. The require command imports code from another file to the current file, and it knows better than to import the same code more than once in case you're doing a lot of requiring. To use the require command, you just type the word required, followed by the full path and file name in quotes, starting with the drive letter. The file extension is optional, and here I have an example, require, quotes, yada yada yada. By default, Ruby will also check certain directories included in the global variable $load path, which usually includes the current directory. So if you'd rather, you can start your file path from one of these paths included in the load path variable. If you didn't know, // refers to the current directory, // will go up a level in the directory tree, and listing a directory name followed by / will go into a directory down the directory tree. For example, dot slash, yada yada yada. If you didn't know the list of paths included in the load path variable, you can run a simple one-line Ruby program here, puts $load path, and it'll spit out all of the default file paths. Now that's the require command. It also has a sister command called the require relative command, which works pretty much the same way. It's an alternative to the require command, but it always starts from the current directory and expects a relative file path. We have an example here, and in this case there's no need to include the dot slash to refer to the current directory. You're just always going to start there by default. So for demonstration purposes, I think we're just going to pull out the athlete module, stick it in its own file, and then import it with the require relative command. It tends to be the more favored of the two commands, and I prefer it because it means you don't have to worry about what's in that load path variable. So let's go ahead and cut this guy out. We'll save what's left. Open a new file, paste the module, and we'll save this file as athlete.rb, all lowercase, and save as type all files so we don't get that txt tacked to the end. And now pay attention to where we're going for our path. We're going to go up a level, into modules, and save. Okay, so we'll go ahead and close that. Open our practice file again. Require relative, and again it was up a level, into modules, and then the file is called athlete.rb. The RB is optional, so we'll leave it off. Save it, run it. There it is, and there we go. That is how you import code into your program, and on that we are going to call it a day. I thank you for viewing. I hope you learned something and had a little fun, and I also hope you have a good day.